What I'm going to demonstrate in this video is evaporation again. So the idea of evaporation is that some of the molecules will randomly acquire enough kinetic energy to change into the gas state. And when that happens, if it's possible for them to drift away, sometimes they will. And if enough of them drift away, then the liquid will evaporate. Molecules will drift away and take the energy with them and result in the evaporation to take place. So what I'm going to try to do is put some acetone. So I have acetone, 2 samples of acetone. I'm going to put them into the dishes and I'm going to cover one of them. And so in doing so, hopefully we'll be able to see. And the purpose of the paper towels is so that there's some contrast, so that the GoPro, which is on time lapse, it's going to be taking one picture every 2 seconds. So the purpose of the paper towels is to make it obvious that the evaporation is taking place. So get this in here. There'll be a small puddle, and this one is going to be outside, exposed to the air. And then this one is going to be covered. And what we're expecting to see is that there's evaporation in one case and not in the other. So we'll let the GoPro run for a little while, and let's see what happens. Okay, so the GoPro's been running and the acetone has been evaporating, except on this side where it was covered, you can see that the paper towel is still wet, and below the paper towel is still a puddle of unevaporated acetone. Under this paper towel is a dry glass dish. So the evaporation took place in the uncovered because why? Well, the explanation is quite simple. The molecules that acquired enough kinetic energy to break free, in the uncovered example, they drifted away and they took the energy with them and they are gone. Whereas under the cover, the gas molecules of acetone, as it randomly jumped up into the gas state, they would stay close to the surface of the acetone, and eventually they would hit the surface and perhaps transfer their energy back and become a liquid again, or exchange places with a molecule there. But an equilibrium between gas molecules and liquid molecules for acetone inside the covered dish developed. And in that equilibrium state, the exchange of molecules becoming gases and becoming back to liquids and up to gas and back to liquid, that exchange rate equalized, thus the term equilibrium. And that's why this one, the one that was covered, is still. Now, if I leave it uncovered not very long, it will also evaporate and be all gone. So that's how evaporation works. So when the molecule jumps up to the gas state and escapes, off it goes, it drifts away, taking the energy with it. If the liquid is covered, then the closed container or the closed environment of a covered liquid, an equilibrium state develops, and sort of foreshadowing a concept called vapor pressure. So a vapor pressure develops. A certain number of acetone molecules are in the gas state, a certain number in the liquid state, or and they're back and forth in equilibrium. So hopefully that is a worthwhile few minutes to look a little bit further into the evaporation process.